So in this lesson, we're going to be looking at neutralization reactions and then also looking at what happens with salts when they're added to solution and the reactions that occur as a result. So first of all, let's look at a neutralization reaction. So remember, neutralization reactions are simply reactions that occur between an acid and a base. We've already looked at that. Now we're going to take it one step further because we can actually now, because we know what are strong acids and what are strong bases, weak acid, weak bases, we actually can take those reactions, which are double replacement reactions, and we can actually write the net ionic reaction to see what actually occurs. So keep in mind that strong acids and strong bases, they are going to completely dissociate in solution, meaning they're going to completely break up into their ions. For weak acids and weak bases, we assume that they don't. So they're going to stay together. They're not going to break apart into their ions. So if I were to react a strong acid with a strong base, so for example, HCl and NaOH, let's actually first write the neutralization reaction, the complete double replacement reaction. So I have hydrochloric acid, HCl, reacting with NaOH. So my products, remember it's innies and outies. So hydrogen is going to react with hydroxide, H and OH, which forms H2O. Na is going to react with Cl, which forms NaCl. So your products will be NaCl and H2O. All right? So that's nothing new. We did that in first year chemistry. Now what's new is now we actually have to break apart what's soluble and what's a strong acid or a strong base. So hydrochloric acid is a strong acid, which means it's going to break up into its ions. So it's going to break up into H plus and Cl minus. If it were a weak acid, it wouldn't do that. It would stay together. NaOH is a strong base, so it's going to break up into Na plus and OH minus. Okay? And then NaCl, because you've got a group 1 metal there, it's going to be soluble, so it's going to break up into Na plus and Cl minus, and then water is going to stay together. So keep in mind to write out your final net ionic reaction, you're going to cancel out anything that is the exact same thing on both sides. So my Cl's are the exact same, I'm going to cancel them out, and my sodium ions are the same. And so my overall reaction here is just going to be hydrogen ions react with hydroxide to produce water. All right? So that looks really nice and pretty because you've got H plus OH minus produces H2O, which is what we were told that a neutralization reaction is. You have an acid and a base and it produces water and then a salt. But the salt, because it's still dissolved in solution, we actually ignore it because it has nothing to do with the reaction. Well, what if it's not quite so pretty? So let's look at a strong acid and a weak base. So for example, here I've got HCl and NH3. So HCl reacts with NH3. Keep in mind, this is a little bit different than just a typical double replacement reaction because NH3 is going to stay together. It's not going to be N with Cl and H with H3. That doesn't really make sense. So since HCl is my acid, it's going to produce Cl minus because the hydrogen leaves the HCl and NH4 plus, ammonium. All right, so it's a little bit wonky, but that's fine, okay? I'm going to break up anything that is a strong acid or that's soluble. Well, the only thing that's a strong acid here is HCl, so it's going to become H plus and Cl minus. Now, since ammonia is a weak base, it's going to stay together. I have Cl minus, and NH4 plus is just an ion, so I'm going to keep it like that. Now, notice the only thing that stays the same on both sides are my Cl minuses, so those will cancel. So I have for my final reaction, H plus NH3 produces NH4 plus. Now, on the AP, on a test, on a quiz, on homework, whatever, you only have to write the last line. So if I look, for example, for the first example, HCl and NaOH, I know that HCl is a strong acid, so I know it's going to break apart into ions. I know sodium hydroxide is a strong base. It's going to break up into its ions. So in my head, I already know the net ionic. H plus Na plus OH minus produces H2O. Okay? For the next example, HCl and NH3, I know that HCl is going to break apart. So I would only write H plus NH3 produces NH4 plus. I know the Cl minus is not going to matter. All right, so if you have a strong acid or a strong base, you can ignore the ion that goes with it. So for HCl, ignore the Cl minus. For the NaOH, ignore the Na. For the HCl, ignore the Cl. All right, so let's look at another example. Here I've got a strong base and a weak acid. Okay, so I'm going to show you the entire double replacement reaction, but if we do what I just talked about, NaOH is a strong base, so I'm going to ignore the Na. So here I would just have OH minus reacting with, well, HF is a weak acid, so I've got to keep it together, OH minus plus HF, okay? OH minus is going to steal the hydrogen from the HF, so it's going to become water, plus F minus. But let's see if that's true, okay? So I'm going to write out the whole reaction. So NaOH plus HF, double replacement reaction, you're going to have NaF and H2O, okay? Inies and outies. Break apart anything that's a strong base or acid and anything that is soluble. So NaOH is a strong base, so Na plus OH minus. HF is a weak acid, so it's going to stay together. NaF, because sodium is a group 1 metal, that's going to break apart into Na plus and F minus. And then you have water. So as I said, the sodiums cancel, and all I'm left with is hydroxide reacting with hydrofluoric acid to produce F minus and H2O. So again, if you have an ion with a strong base or strong acid, you can actually just ignore it because you're going to end up canceling out anyways. All right? All right. So you guys are going to do some practice with that right now, so pause the video. The next thing that we need to talk about are salts. All right? So I'm going to show you examples to show you how to predict how a salt will react in a solution. Is it going to act like an acid, a base, or will it be neutral? So for this problem, I asked you to predict whether the following salt acts like an acid or a base. If they do act like an acid or a base, I ask you then to show the reaction with water. All right, so KF. All right, how the heck can I determine if KF acts as an acid or a base? So here's where you're probably going to have to rewatch this explanation. I have 2 examples you really need to pay attention. All right, so if you look at KF, okay, thinking back to those reactions we just did, where would that KF have come from? What could form KF? Well, I know that the potassium had to come from, because it has a positive charge, it had to come from KOH, the base. KOH, because you can't have KF, KH, that doesn't make any sense. So that came from KOH, and the F came from HF. So in your head, always think, okay, where did this come from? K came from KOH, F came from HF. Well, KOH is a strong base, okay? So if an ion came from a strong either acid or a base, it does not contribute to the acidity or basicity of that salt. Instead, it's going to be neutral. So since potassium ions came from a strong base, it in solution will be neutral. It's just a fact, okay? Don't try and overanalyze it. It's going to confuse you. Just look at it. K came from a strong base. We're going to ignore it. It's neutral. F came from a weak acid. It came from HF, which means it is going to be either acidic or basic. And so here's how I remember whether or not it's going to make it acidic or basic. It's a quick trick, all right? The reasoning is it came from HF, therefore F minus will be a base. But the way that I remember it is the first ion would make it acidic if it came from something that's weak. The second ion, if it came from something that's weak, would make it a base. Acid before base. Okay? So if K had come from a weak base, it would be acidic. If F comes from a weak acid, it would be basic. Well, since F came from a weak acid, this will make the solution basic. Okay, so I have F minus. F minus is going to contribute to the solution. It's going to act as a base. So let's see how that looks. So we talked about base dissociation reactions already. So F minus is going to react with water. And since it's a base, it's going to accept hydrogen, so it's going to become HF plus OH minus. All right? So let's look at another problem. NH4Cl. So remember, NH4 came from a base, Cl came from an acid. If NH4 came from a weak base, it will be acidic. If Cl came from a weak acid, it will be basic. So what did NH4 come from? NH4 came from NH4OH. NH4OH is a weak base, which means this is going to be a weak acid because remember, acids come first. Cl, what did Cl come from? Well, since it's Cl minus, it must have come from an acid because it would be HCl where it came from. HCl is a strong acid, which means Cl minus is neutral. So NH4 plus is going to act as an acid. Okay, so NH4 plus water. I'm going to have it, remember, for acid dissociation, I could just break that apart into the 2 ions, or I could have it react with water, and I decided to have it react with water. Okay, NH4 plus is going to donate a hydrogen, so it's going to become NH3 plus H3O plus. The other way I could have written this is just writing NH4 plus produces NH3 plus H+. Either way, it's the same thing. So let's look at an example. Here it tells you that you have a solution that's made from sodium hypochlorite being added to water. Okay? Now, if you start with 0.60 moles of sodium hypochlorite, what is the pH going to be? Well, the first thing we got to figure out is what part of this salt is going to be involved, and is it going to be acidic or basic? Well, sodium, Na, came from sodium hydroxide, which is a strong base, so I can ignore sodium. Hypochlorite, the hypochlorite ion, came from HClO, which is a weak acid, which means ClO minus would be a weak base. So ClO minus is going to be a base, which means when it reacts with water, it's going to produce, well, it's going to accept a proton from water, so it's going to become HClO and hydroxide. And so now what you have in front of you, even though this seems like a totally different question, it's exactly what we are working with weak bases. I'm going to ice it, and then I know my initial concentration of the hypochlorite ion. It's going to be 0.60 moles divided by 2 liters to get the concentration, so that would be 0.30. Remember, I ignore water. My HClO concentration is 0, and my hydroxide concentration is 0. So what I'm going to do, I'm going to subtract X from the reactants, add X and add X to the products, which gives me 0.30 minus X for my reactants, and then X and X for my products. Now I know my base dissociation constant, so I'm going to write that really quickly. So my Kb equals, well, my concentration of hypochlorous acid times the concentration of hydroxide all over the concentration of my hypochlorite ion. Now I can put in everything I know. Well, I know my Kb, it's 3.33 times 10 to the negative 7th. I know that the top, the numerator, is going to be X times X because those are my products, so it's going to be X squared. And I'm going to divide that by 0.30 minus X. Well, using my law of 100, 0.30 divided by 3.33 times 10 to the negative 7th is going to be larger than 100, so I can ignore that X. So all I need to do now is take 3.33, multiply that by the 0.30, and then square root that. So I end up getting 9.99 times 10 to the negative 8th equals X squared. I'm going to square root that, and what I end up getting for my answer is 3.16 times 10 to the negative 4th. Now that's my concentration of hydroxide. I can now take the negative log of that and find my POH, which is 3.50. Okay? What I now can do, finally, is I can take 14, subtract 3.50 from that, and that gives me my pH, which is 10.50. Okay? So while the salt questions might look totally different, they're the same as the weak acid or weak base problems, except for the fact that you need to determine what is acting like an acid or a base. So in this case, it was the hypochlorite ion that was acting as a base. So in this problem, what it gives you is nitrous acid, so HNO2, which is a weak acid. And so what you should have done is set this up. It's an acid dissociation reaction, so you're going to have hydrogen ions and your nitrite ions, and then you're going to ice it. Your initial concentration of the nitrous acid is 0.085, and then you should have completed this using the Ka and calculated your concentration of hydrogen ions and therefore your pH. The only difference here is now instead of having a 0 molar concentration of your nitrite ion, you're going to have a concentration. So hydrogen ion is 0, while your nitrite concentration is 0.10. Now I'm going to treat it just like I did before, minus X plus X plus X. So what I end up getting at equilibrium, 0.085 minus X, X, and 0.10 plus X. Now I can write my acid dissociation expression. My Ka equals concentration of H plus times the concentration of nitrite divided by the concentration of nitrous acid. Now I can plug those values in. My Ka is 4.5 times 10 to the negative 4th. Concentration of nitrite ions is 0.10 plus X. Remember, I can ignore the plus X, since if I were to take 0.085 and divide it by 4.5 times 10 to the negative 4th, that ends up being greater than 100. So I'm going to put 0.10 there, so X times 0.10, not X times 0.10 plus X, and then divide that by 0.085 because I don't subtract the X, which makes my life a lot easier. And now I can just solve for X. So X equals 0.0038. That's my concentration of hydrogen ions. and then take the negative log of that, and that gives me 3.42. So that's my final answer. Now compare that to what you originally got when you didn't start off with any nitrite ions. Which pH is higher? Make sure you can answer that when we get into class.